The Levelok cage holding system is well established as a means of holding a conveyance in a mine shaft by means of clamp units gripping onto steel guides in the shaft. The clamps being powered by a power pack mounted on the cage and activated when a compressed air supply is connected to the cage at the loading station. A typical hydraulic circuit diagram for the cage clamping system is shown, with one power pack operating 2 clamp units. The need for an emergency braking system on a mine cage resulted in an accumulator, pre-charged with nitrogen gas, being added into the circuit. The function of this being to store oil under pressure, so that it is available to apply the clamps at any point in the shaft under emergency conditions, such as the occurrence of a slack rope or a rope failure. The accumulator would be charged up the first time the clamps were applied, and it would remain so and not affect the normal operation of the cage holding system. The solenoid-operated valve, which connects the oil under pressure in the accumulator directly to the clamp cylinders, is triggered from a reliable slack rope monitoring device mounted on the cage, simulated on the test rig with a limit switch. To demonstrate the operation of the emergency braking system, Horn Hydraulics uses a free-fall test rig with a 5-meter vertical track, one upright of which is a 6-inch channel section which represents the shaft guide. The test mass, which represents the cage, comprises a Levelok clamp with a guiding framework on top, and on this is mounted the accumulator and solenoid valve. The whole assembly has a mass of 220 kilograms. The accumulator is charged up by an external pump unit, and a ball valve locks the oil in before the hose is disconnected. The test mass is hoisted to the top of the track by a small winch, and it is then allowed to rest on a steel pin while the hoisting rope is detached. In this case, electrical power is supplied to the test mass through a trailing cable, and an onboard limit switch is used to trigger the solenoid valve after the clamp has fallen a preset distance, 60 millimeters in this test. The support pin is retracted hydraulically and the test mass free falls. The response time from tripping the switch, which is equivalent to the slack rope signal, to the start of retardation when the clamp shoes contact the guide, is about 3 seconds. And this is illustrated by the interval between the 2 pilot lights switching on. By the time the clamp is applied, the mass has achieved a velocity of 4 meters per second, but the clamp then brings it to rest within 1,5 meters, which gives an average deceleration rate of about 0.6 g, and this retardation can be adjusted by varying the clamp pressure and thus the decelerating force. Let us look at the drop again and note how controlled the retardation of the test mass is. This emergency braking system illustrated can equally be applied to full-sized cages, the clamps being selected to support the full weight of the cage with attachments and payload, and it would provide protection for the personnel traveling in the cage if slack rope or rope failure were to occur. The emergency braking system could also be used to replace the safety dogs used on some mines, and there would be distinct advantages in being able to use steel guides, as clear-grade Canadian pine, which is necessary when using dogs, becomes increasingly expensive and difficult to obtain. The Levelok emergency braking system is another development from Horn Hydraulics in an endeavor to make hoisting operations in mine shafts safer.